A measure of variation is a measure that describes the spread or distribution of the data set. One measure of variation is the range. So, the range of a data set is the difference of the greatest value and the least value. Find the highest value, find the lowest value, and subtract them. So, for example, here we have ages for show A for a reality cooking competition. And then we have some ages for show B. So, in order to find the range, what you do is first you order the data. So, for show A, we would start with 19 and then go all the way up to 31. And the range, you would take the highest value, 31, subtract it from the lowest value, 19, and your range is 12 years. So show A has a range of ages that range within 12 years. Show B, order them out, 19. The highest range in this one is 48. 48 minus 19, show B actually gives you a range of ages of 29 years. Next up, we have standard deviation. And don't run. I know it looks scary, but it is not bad. And we will take these step by step and even use a table when we solve these. The standard deviation of a numerical data set is a measure of how much a typical value in the data set differs from the mean. So, how far is it off from the average? And so people use this data when taking analysis of things and seeing like, okay, how much is that really off from what is average? So it's an important measure of data. So we use the symbol sigma for standard deviation, and it kind of looks like that cursive T there. And there's their formula, and it looks daunting, I know, but I promise we'll go through the steps and you'll find it manageable, okay, as long as you follow the steps. So where n in this case is the number of values in the data set, the deviation of the data value x is the difference of the data value, and the mean of the data set is going to be x minus x bar, the average. Okay, so first off, step one, find the mean. Okay, so we find the mean, which is the average. So you add up all the numbers divided by the number of numbers, there's your average. Step two, find the deviation of each data value. So that would be your data minus whatever the average was. So how far different is it from the mean? Square that deviation, find the mean of the squared deviation. This is what's called the variance, and then take the square root of the variance. Easy, right? So a small standard deviation when we get that answer, so this is, to analyze our data, means that the data are clustered around that mean. So it means that they're not spread out that far. The range is not that far from the mean, the average. A large standard deviation means that the data is more spread out. So it's not all scattered in, it's just like data kind of all over the place. So you guys ready to do some example problems of this? I think we are. Let's go, right? All right, so let's do some quick examples on standard deviation. We are going to actually use Google Sheets for this because it does make adding up numbers and finding averages easier. And this is also like a really good quality to have to know how to use Google Sheets. It's definitely something you go into an interview, you can put down that you are capable of using Google Sheets. So again, just a reminder here, we're doing a measure of a variation is a measure that describes the spread, the distribution of the data set. One measure of variation is the range. The range of a data set is the difference between the greatest value and the least value. So that one's a little bit more straightforward. Standard deviation is the standard deviation of a numerical data set is a measure of how much a typical value in the data set differs from the mean. So again, if the standard deviation is large and like a big number, then it differs a lot. If it's smaller, then the data set is all clustered together. So it is a variable that is used to, like look over data and see like when you're doing a data analysis and whatnot is something that's used. So there were some steps here. And we're going to go through these steps actually using Google Sheets, like I said. So it's a good idea to have these notes or screenshot these steps because we will be using them. The first question, though, this one's just 2 reality cooking shows, select 12 contestants each. The age of the contestants are shown. After the first week, the 25-year-old is voted off the show. Of show A, and the 48-year-old is voted off show B. How does this affect the range of ages of the remaining contestants on each show? Explain. So right off the bat, for show A, the first thing you want to do is make a list of, let's do a text box. For show A, let's list them in numerical order. So for show A, looks like the lowest age is 19. And then we go to 20, another 20, 21, 22. Where's another one here? Not 23, not 24, 25. Taking our time, sweet time here, right? 27, 27. After 27, we get to 29, 2 29s. 30. And I think that's it. Oh, we got a 31. Let's make sure that we have 12 here. So that's show A. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, great. So that's our data. And so the range in this case is just going to be the greatest number minus the least number. And so that is going to be 31 minus 19. Calculator, because mental math is fun. Well, all right, so our age range is 12. But it says after the first week, the 25-year-old is voted off the show, off of show A. So if the 25-year-old is voted off the show, is that going to change the age range? No, you're still going to do 31 minus 19. So there's going to be no change. Voted. Okay. But let's think about for show B. So show B, we do have a different age range. So let's go ahead and put that in there. So what we have here, 19, 20, 21, 22, 22, 24, 25, 25, 27, 27. Let's see where we at. We're going 27. What's next? I think just all the way up to 32, then 48. Hopefully I got them all. You think I got them all? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Phew. Okay. Let's check out the range here. So this time, let's just do a new text box. So our range is going to be 48 minus 19, which is 29. So 29 years is our range. And I'm going to actually change this so that we know that that's the range. So this one, though, it says, how does it affect if the 48-year-old is voted off of show B? So it is going to affect it, because if the 48-year-old is not on this show anymore, so they are cut, our range is different. And so our new range is going to be 32 minus 19, which is 13. So range does depend where the numbers are changed and whatnot. Okay. Next problem, this one is the standard deviation problem. We still do have our cooking show. Find the standard deviation of the ages for show B. Round your answers to the nearest hundredths. Okay, so for this one, and I'm going to link this here in this page, but I am going to use Google Sheets. So this is what I'm going to use for Google Sheets. I just did like a standard deviation template and all the variables and whatnot. And so I will link this for you guys, but you'll see how it is easier using Google Sheets to just find the standard deviation. So the first thing, the step you want to do, and so I'm going to actually post these steps down here again. Let's copy these. And let's save to clipboard and paste them here. All right, so there's our steps again. And so I'm going to use these on the sheets first. So the first thing you want to do is find the mean, which is your average. And so we're going to use show B. So I'm going to put all this data in my spreadsheet. Okay, so step 1, find the mean. So let's go ahead and go to here. And I'm going to put this data in. So these are our numbers, X. So I already put them in here. We have 12 numbers, 19 through 48. And so those are my numbers. First thing, this box is kind of where I'm going to find the data. And the end goal here is to find this red number, which is that standard deviation. So the first thing we want to find is that X bar, which is the mean. And so that's the sum of all the numbers divided by the number of numbers. So I need to sum all these numbers up first. So let's go ahead and put this in this box here. So to sum that, I'm going to do the equals and then sum and then parenthesis, and I'm going to add these all up. And in parenthesis and hit enter. And that's my sum of all of those numbers. And I'm going to change the color to that so that I know that that's not some of the data, that's just the sum. Okay, so we have the sum of all those numbers. The mean is the sum of the numbers divided by n. So in this case here, I'm going to do equals, and I can do 312 divided by 12, or I could hit that. Let's actually do that here. So let's do, you'll kind of see how this works. Oops, sorry. It's not what I wanted to do. Let's just do, giving me all sorts of errors. Let's do equals 312 divided by, and that was the number of numbers, which was 12. And if you want to like set this up so that you're doing, you can put that number in here and you can use that table, that's fine too. So that's our mean, 26. So 26 is what's going to go in all of these columns here. Okay, because the mean doesn't change. The mean's just 26. The next step, and if we go back to our steps here, is to find the deviation of each data value. So X, so the number, minus the mean, X minus X bar. So in our X minus X bar. So we're going to do this number minus this number. So it's nice here. We can just hit equals, parenthesis, and I'm going to do this number minus this number. And you'll see why I chose them. It's not just put 19 minus 26, because you can autofill this up and it'll do all of these for you, which is pretty nice, right? Okay, let's autofill. Awesome. Okay. This one I did not want to autofill. So actually, let's just, if you didn't autofill it and you just did it that way, what you can do is you can grab this box and grab the bottom right corner and pull it down, and it'll also autofill. So all these numbers are this number minus this number. Kind of cool, right? I have this here because that's what this number is going to be. And so I'll put that a color also. All sorts of different colors here. All right, then the next step, we're just moving down this chart, is to square this. So again, looking at here, square each deviation. So it was the previous step squared. So we're going to take this number and square it. So again, we'll do this equals, and I'm going to put this number in, and I'm going to put parentheses around it because to square it, we want to make sure we square it all, even with the negative, and then shift 2 squared. So hit enter, and let's not autofill. So I'll show you again how to do that. So again, this is this number squared. So again, you should have a negative squared as a positive. So all these numbers should be positive. Make sure if you didn't put the parentheses, it wouldn't show up positive. We take that and we pull it down and we get that number. Okay. All right. Next step. Is having fun yet? All the steps. Step 4, find the mean of the squared deviation. This is called the variance. So the mean of the squared deviation means the average of all of those numbers. So we want to find the average of all these numbers. So we're going to sum. This little sigma sign here means the sum. So we're going to average all of these numbers and find that here. So we're going to sum those up, equals sum of all these numbers. Okay, 670. The variance, though, is the sum of all the numbers divided by n, the number of numbers, 12. So this is going to equal 670 divided by 12. Okay, and our standard deviation, don't want to autofill. Standard deviation is the square root of the variance. So we're going to take the square root of this number. And this is nice because you can just do this right in here when you know these symbols. So square root, we would do equals. So anytime you want to do a math operation, you start with equals. We use square root, SQRT. So you can see they pop up sometimes with like what you want to do here, square root of this number. Enter. And there is your standard deviation. I'm going to go ahead and post this in that assignment. Crazy, right? And I know you want probably more. You want more, right? You want to do more of these. And there will be more. You'll have plenty to work on in your assignment because it is a good tool to know how to use Google Sheets as well. So there's your standard deviation, 7.47 years approximately. Be sure to put summary in here if you want. You can say, I like using Google Sheets. It's been fun. Or not.